Hello and welcome. In this lesson, we'll explore properties and laws of logarithms. Remember that the term logarithm is just another name for the word exponent. And when we operate with exponential numbers, we have to honor the exponent properties. Some of the exponent properties are a to the power of 0 equals 1, a to the power of 1 equals a to the power of negative x equals 1 over a to the power of x. Just like with exponential numbers, when operating with logarithmic numbers, we must follow similar rules or properties, which we call logarithmic properties. Log with base a of 1 equals 0, and that's because the base a raised to the power of 0 equals 1. Log with base a of a to the x equals x, and that's because the base a raised to the power of x is a to the x. A to the power of log ax equals x. That's because the exponent, log with base a of x, is what we need to raise the base a in order to obtain the exponential number x. So the exponent we need, or the log we need to raise the base a to obtain x. Now, why do we need all these formulas? We need to learn how to operate with logarithmic terms because we need to learn how to simplify logarithmic terms because they help us solve equations that involve logarithmic terms. And in return, they help us solve problems where logarithmic equations are needed to solve them. The next one is one very, very useful formula, probably my favorite. And this formula is based on all the logarithmic properties. It is called the change of base formula. And it's very easy to remember. We say that the log with base a of b equals log with base x of b over log with base x of a. It probably seems complicated, but here we go. I'm going to rewrite this one separately. So if we have log with base a of b, then we create a fraction. In both numerator and denominator, we'll have log. And you can think of this number as a fraction b over a. So you can place b in the numerator, a in the denominator, a at the bottom. And we can give both these log terms any base we wish, providing that we choose the same base for both of them. So here I created this little box for you to write the logarithmic properties one more time. I find that it is helpful when you rewrite them because they make more sense when you see them the first time. Remember, the learning curve doesn't just go up, the learning curve goes up and down. So we learn something, we tend to forget it, and we relearn it and we forget it. So repetition is very important, especially when you have just learned something, when it's fresh in your brain. Anyway, so moving on to using the properties we just learned, or should I say have fun with using the properties we just learned. Here we go. We have log with base 4 of 64. The question is asking to simplify using the log properties. So this time, I am going to keep the base of 4 and rewrite 64 as an exponential number, power 3. We're going to say that the answer is 3 because we know that log with base 4 of 4 to a certain power equals the number itself. Next, we have log of 20 with base 23 of 1. So we'll say that the answer, whenever you have a 1 inside the log, must be 0. And here's a little proof in here. It's because 23 to the power of 0 equals 1. Next, we have log with base 3 of 1 over 27. So I will convert 1 over 27 into an exponential with base 3. I'm taking the steps slowly. Obviously, you can do this in one single step. So 1 over 3 to the power 3 is 3 to the power negative 3. And notice how here we have just negative 3. The two bases here will match, which makes the answer equal to negative 3. Next, we have 7 to the power of log with base 7 of 9. So that's the third property. So that means that the answer must be 9 because the base in the exponential number with the base in the log are equal. And here goes a funny looking one. It's not too scary. You know that radicals are nothing but rational exponents. So we'll rewrite this log term, keep the base of 5. And let's go slowly, one at a time. Let me zoom in here. So we have number 25. We know that 25 is an exponential with base 5. So I'll write 5 in here, squared. And then 5 squared is brought to the power of 3 over 2. That's the power you see inside the radical. And then we have the third root of 3. Now the third root of 3 is nothing but a rational exponent 1 over 3. So let's simplify a little bit more. We have the log with base 5 of number 5, and now we are going to marry all these exponents together. We have the power of the power of the power, which means they will multiply to give 2 times 3 over 2, and then times 1 over 3. Interesting, isn't it? So that would equal log with base 5 of 5 to the power of, notice how the 2's will simplify, and the 3's will simplify, and we are left with the power of 1. The answer is 1. Very sneaky, I would say. So we're moving on to one more example. 5 log with to the power of log 5, 8. That would be 8 minus 3 log with base 3 of 5. 8 minus 5. The answer is 3. Now we're going to use the change of base formula to determine the value of each expression, and we are going to discover some very interesting patterns here, so prepare for it. So what we have is log with base 9 of 243. So if we want to use the change of base formula, it means that we can make this into a fraction, log of 243 over log of 9. Now remember that when we use the change of base formula, we need to use the same number here in the base. So what I'm thinking is the rule that states that when we have log with base a of a to the x, the answer is x. So what I'm trying to do here is try to come up with a base in here, and I want this base to be also the base of the numbers inside log. So the number that I think that fits into both of them is the base of 3. So I will give both numerator and denominator a base of 3. And now it's time to work on the numbers inside the log. So we have log with base 3 of, so I know that 3 to the power 3 is 27, to the power of 4, 81, and to the power of 5, 243. So 3 to the power of 5, and log with base 3 of 9 will be 3 squared. So remember that when the bases here match, the answer will be just 5. And down here in the denominator, we have the same pattern, the bases match, then the answer down here will be 2. 5 over 2 is the answer, and we didn't even use a calculator for it. Moving on to the next question, we have log with base 8 of 128. So again, I'm going to make a fraction. I'll write log in both numerator and denominator. 128 goes on top, 8 at the bottom, the base. And now I have to think of a base, and I need to use the same base in both of them. So the number I can think of is the number that can be written as the base, or can help me write each number in exponential form. And whenever I deal with even numbers, I always consider the base of 2. So let's give it a try. Then we have log with base 2 of, for number 8, I'll do this first because that's the easy one, 2 to the power of 3. Now, I know that 2 to the power of 4 is 16, 32, 64, 2 to the power 6, and 128 is double of that. So I would say that 2 to the power 7 will give 128. So you can look at this as if you are simplifying, but don't do the simplifying, right? Let's remember the pattern, because that's not how it actually works. There is no simplification there. But just a shortcut to remember a certain formula. So 7 over 3 is the answer. Let's take a look at the next example. We have log with base 1/6 of 216. Again, same thing. Write log in both numerator and denominator. Write the number inside the log in the numerator, the number in the base in the denominator. Think of what number to use for a base in each of them. So when I see number 6 in here, the only base I can think of is the base 6. And now I will work on making each number inside log an exponential with base 6. So the only thing I can think of 1 over 6 is 6 to the power of negative 1. Notice how I always start from the easy part of the problem. And I find this strategy kind of soothing in a way, because I kind of feel more accomplished, and you get one of the things out of the way. So 216 will be 6 squared 36 multiplied by 6 to 16. So that must be 6 to the third. And the answer would be, again, same pattern here. So the bases are the same. So 3 divided by negative 1, or simply negative 3. Let's move on to another example. This is our last example. So in the last example, what we have is log with base 243 of log of the fourth power of 729. So log and log. And fourth root of 729, which, I think it would be a good idea to write it as an exponential number. The power will be 1/4, and 243 will be in the base. So 243 reminds me of a base of 3. So I'm thinking of a base of 3 for both numerator and denominator. And here we go. We have to work now on, I'm going to continue here, log with base 3 of 729. So I know that 3 to the 4 is 81. 3 to the 5, 243. And if you multiply 243 by another 3, you get 729. So that means that 729 is 3 to the power of 6. And 243 is 3 to the power of 5. So notice that now the answer is simply 6 divided by 5. Okay. So as you see in here, the change of the base formula helped us simplify each and every expression. And not only that, but you probably noticed that the answer was always the ratio of the powers. So we are going to say that if we have log of some number a to the power of m with base a to the power of n, the answer will always be m divided by n. So the pattern is consistent in every answer. So 5 over 2, 3 over negative 1, right? And etc., etc.